first of all, an attacker is always going to search for the easiest path to his goal, being to hack a car, to hack a fleet, to produce some damage, or to take some advantages. An attacker is just like water; it's going to find the easiest road to the hills. And right now, with the revolution of software-defined vehicle, with the extent of connectivity we are having, the vehicle is changing its signification. In the past, traditional vehicles were actually one project. You had one vehicle, you had a couple of ECUs, software that we deployed on them, you send them to the team, and you forgot about them. Okay? This is changing. This is rapidly changing. Not only that, you cannot allow yourself to have vehicles out in the fleet that are not maintained, do not get new functionality, are not updated, but also a vehicle is no longer only the iron and the wheels and the internal. The vehicle is the whole data ecosystem surrounding it, the connectivity, the personal data that you're having in the vehicle, the value added services, and all surrounding this thing is the new vehicle. So when we're thinking about cybersecurity, we need to think about cybersecurity and what the vehicle indeed is standing for means. It's not only the thing that you see physically on the road, it's the backend system, it's the cloud system, it's the connectivity, it's the data stack, it's the data authenticity that you use to make your decisions on the vehicle. And this open and dynamic connectivity brings with itself more attack surfaces. As soon as you have vehicles connected, you have ways to attack the vehicle not as an individual one vehicle, but you can attack fleets in a region, or you can attack fleets globally, or you can extend attacks from one vehicle to the other. So this whole topic of how you secure vehicle is going to change rapidly over the next couple of years. And it is going to change in tune with the way that you are actively adding functionality. You must always think about how you actively secure these things. Um, and I have mentioned that there have also already, and there are already being attacks to this. And there are attacks against individual vehicles, but there are also attacks that you're seeing at fleet level. I have two interesting ones here. So the first one, this is a geopolitical effect on an ecosystem attack. You have all heard about the little situation that happens in the Eastern Europe with Russia and with Ukraine. One of the first things that happened is actually that the people from Ukraine have attacked the Moscow transportation, and they coordinated all the taxis in the region to come to a certain place in Moscow during a very important meeting of the government. So they actually blocked the city for a couple of hours. Okay, this is an example of an ecosystem level effect that we might have, where you have a situation where you can use the transportation and the connected vehicle, in this case, the other dispatching, in order to cause disruption. This is not at the individual vehicle level, this is at an ecosystem level. So the vehicle is not only the car that you have in terms of stealing the keys and stealing a car or stealing the infotainment. If you're thinking about more transportation and connected transportation infrastructure, you can think about the long-range autonomous driving systems that are being developed for North America and for Europe, hub-to-hub systems. They are having effectively a 40-ton system that is driving by himself on the street, that is can be attacked at the dispatch level, at the guidance level, at all the levels. And we have been lucky up until this point in time that nothing more serious than these things have happened, but the vulnerabilities are out there. The second thing that is interesting is a topic that has consequences in China. It is the topic of a fatal crash to ADAS systems. It is not clear if this was a cybersecurity or a safety issue, but nonetheless, the consequences of these two effects are the level of regulation. So you're going to have new regulations being imposed on the manufacturer and on the ecosystem providers in order to make sure that these vehicles are going to be safe and the fleets are safe for the street. So this is the stage. Now, as CYMOTIVE, I have told you that we've been doing this for like 12 years. And this is not a theoretical thing. Right now, we analyze vulnerabilities for the fleets, for vehicles that are going to come on the road in 3 years, in 4 years. And for right now, when we're doing analysis on ECUs, we see an average of 700 vulnerabilities for each ECU that is going in the fleet right now. And we're having also ECUs that are going in the fleet with 9,000 vulnerabilities. That is the state of the fleets out there. And we have also our intrusion detection system that we have on the road in more than 1.5 million vehicles globally. And when we are looking at the amount of attacks that we're seeing, it's around 40 events per vehicle, local and connectivity. And we have only on connectivity that 155 million events per year. So right now, again, this has not led to serious impacts. The attacks are relatively easy for now, but this is changing rapidly. This is going to change rapidly, and this is going to be instrumentalized at the local level, at the global level. Just like you see sometimes for demonstrations in China that some people are sabotaging other people's drones, as soon as we're going to have autonomous vehicles, it's going to start being very interesting. Okay? So this is the stage that we have to face. Now, there's another pressure that comes to us. It's not a pressure only from liability, but of course the regulation has learned about the things, and nobody wants to be disrupted. And right now there are two very big regulation pushes that are happening worldwide on the topic of automotive cybersecurity. If you are from the, working more with regulation, you should know this. On the one hand, you have supply chain regulations. Supply chain regulation is mainly targeting and protecting business model, but also national interest protections. So, for example, you have in US regulations that prevent Bitcoin on a certain types of hardware coming from certain countries for certain high critical applications. You're having the same type of regulation that you are going to see in Europe, the same type of regulation in China. So people are starting to build walls around their countries, around their zones of influence. And then you're having the cybersecurity regulation that have generally mandate everybody that is designing and implementing, deploying these systems to make sure that you develop and engineer your vehicle in a safe and secure manner. These are very serious because without agreement and without compliance with this regulation, you're not going to be able to homologate any vehicles or any issues. These are just as important as safety, just as important as emissions, like everything else. It has the same burden on the OEMs. Right. So this brings also with it the fact that if you are a supplier or an OEM, you have to face different regulation stacks in different markets with different consequences and different types of liability. But actually, it all boils down to the fact that you need to make sure that the vehicles that you develop and this ecosystem that you develop is developed in a safe and secure manner. And what does that actually mean from the front? So from the front, it means that it's no longer enough to have one common development and engineering process for your whole ecosystem. You have to start with tailor to go from the SDD stack, from the platform level to the vehicle to the software application connectivity and cloud. And you have to use different types of methods that are the correct methods for your layer. You have to do this ecosystem of agile and waterfall methods in order to make sure on the one side that you have a safe and secure vehicle platform, your chipsets are secure, the capacity that you need for your crypto processors are enough, and then you must make sure that during the development and on the higher layers, you integrate agile cybersecurity directly in your development stack. It is not enough to come with cybersecurity at the end of a functional development and to hope that you have done the testing, because usually if you do this only at the end, the things that you're going to find you're not going to be able to fix or not going to be able to fix in time to keep your SOP. You know? So that is the pressure that you need to face in order to transition from development cycles for 3-4 years to developing a vehicle in 2 years. It's something that we have to face. So we've been doing these type of processes with OEMs worldwide, and we have been able to develop also tooling and automation to make sure that we reduce this time and we learn some things. So first of all, um, we must change from development from a hardware-focused, PC-focused development to software-led focus for the functional aspects. It's good to have a core platform. The core platform must be secure, but everything about the core platform must use and thought about as a software-first approach. And also in a software-first approach to make sure that the security is built in. Um, and of course, to be very flexible and select the methods that you're going to use in the organization depending on how the organization functions. There's a lot of situations out there with the one that have delayed timelines just because they just apply some standard methods on their development. It has to be tailored on how the organization actually works. What are the teams doing actually in your OEM, and use them and accelerate them with automation and AI. Now this is the point where I'm coming to the AI power. Right now, if you're looking at the vehicle has minimum 10,000 functions. Functions like, for example, suspension control, chassis control, power steering, from the HMI to the REI systems to the entire internal connectivity layer. There are at least 10,000 functions. Somebody made a graph where they are saying that actually the software that you're having right now in your standard vehicle on the road is a factor of magnitude more than you're having in the F22 Interceptor, just from the lines of code. This is not something that you can manage without using intense automation and intense AI to very rapidly assess what is your risk, what is your model, what is your dependency in the vehicle, and help you focus. Remember that I mentioned 9,000 vulnerabilities. If you put people to sort through 9,000 vulnerabilities and to understand which one you really have to fix and which ones you can ignore, it takes you years. And in these years, you're going to have another 10,000 vulnerabilities discovered. So you cannot cope with it other than using automation and using AI. So um, we have been working on these topics and we have been creating our own AI cortex in the past, and we're happy to work together with the colleagues from FPT to deploy this and to use this at large in order to make sure that we understand very fast the dependencies between the software modules, what is the risk model, and rapidly assess new vulnerability out there to the market, to the platforms that you're having, and to understand how the usage of your vehicles is changing with time. Sometimes you develop a vehicle at some point in time, and in 5 years, the same platform is taken to another total different business use case in a total other area, a total other zone. You take it from civil to military or the other way around, and it has a total change on the way that you're using it and the risk mode that you have. It's important to understand this analysis. And of course, if you want to make it happen, you have to embed AI at the core of the development, meaning creating the relationship, understanding the relationship. And we have also created our platform surrounded by AI with cybersecurity management system, security testing. You can see the demos, and I'm sure a lot of the case from the content here from the colleagues. Monitor electric intrusion detection system, which I have already mentioned. And for thank you very much and have a great day.